enhanced data rates for GSM evolution, and also 3G, which is extension of the each that we have. Then that is, what we call, broadband. So 3G cellular mobile technology is the one that's regarded as, broadband cellular network. And I should also mention that cellular mobile networks contribute around 70% of the data on the internet. There are different papers, white papers written in that regard. So that means that studying this architecture is very essential. And 3G is the one that's dominant throughout the world right now. 2G is becoming obsolete, and then we have 3G in most third world countries, in particular. 4G is, also dominant in developed countries. 5G is on the verge. So what is different from 3G, 4G, and then 5G? That is, the point of this speech is to assess that part. I am producing the different types of, architectures that were present in the past, and then what's going to happen when we have 5G. That will be the point. So this is 3G architecture. There are additional network elements, as you can see here. There is what we call GGSN and SGSN. They didn't exist, prior to the 2.5G, which is GPRS. So GGSN and SGSN are important network elements in order to enhance the data rate of the network. That is very essential. We said that in prior types of architectures, the data rate was minimal, but the introduction of GGSN and SGSN, we can have, more data rate, which is 3G has got, for instance, 2 megabits per second, which is theoretical data rate. So these are the elements that are introduced. There is PDN and IMS connection to GSM, as can be seen on the slide. So there is also change in the network elements. The BSC has become now RNC. RNC is radio network controller, and there is some change, hardware as well as software change, incorporated within this change. So we should also note that when we have increment in generation, there is miniaturization of network elements, which is the nature of the architecture as a whole. Because in recent types of generations, we have higher type of bandwidth or high carrier implementation is there. As the carrier frequency increases, there is something that you should know. Since the devices should be half wavelength multiple of the carrier, by nature they become miniaturized, but also they become complex. They become also difficult to manufacture, but still miniaturization exists. And also the number of sites that you require increases as you increase the generation of the implementation of the network. So now there is a change. Particularly, you can also see the RNC part and also the advancement of the data serving platform in the previous networks. This has been enhanced by SGSN and GGSN. GGSN is gateway GPRS support node, and SGSN is serving GPRS support node. So in a way, they replace the already existing GSM and others for voice communication. Now these entities serve data. So there is separation of voice and data at this point as a 3G architecture. Now after that, there is a leap towards 4G. What is different in 4G is that 4G is all IP platform, which doesn't exist in the previous types of architectures.
Professor, sorry to intervene. Professor, a small request. Yes. Maybe your PPT can be in slideshow mode.
Slide.
PowerPoint, yes. PowerPoint can be in slideshow mode.
Slideshow mode. Okay. Let me do that.
Yes.
Let me do that. Like this.
Yes,
is it okay?
Yes, Professor.
Okay. So 4G is the platform that is essential for convergence of networks. Probably you might have encountered this term. When we say convergence, it's not just about the physical layer, data link layer, something like that. But convergence is the network layer and above regarding management of networks. So since this is all IP platform, in this type of generation, we will not have voice service as we know it in earlier CS-based networks. But we can have voice over IP, video over IP, something like that. So if you have 4G coverage in your area, for sure, your operator is not serving you for voice services from that 4G network. Probably they can use the backward compatibility scenario. 3G networks, 2G networks can be used for voice services. This is totally tailored for data-centric or IP-based type of platform. So one important point that we should take is that this 4G mobile technology is all IP, and we will have flat IP type of discussion in our 5G network, but it is the basis for the 5G network, you could say. After 4G, of course, we have intermediate types of networks like LTE advanced type, which is in between 5G and 4G. But the trend that we mentioned earlier, like the miniaturization of terminals and also the site increment, but plus there is also advancement in the air interface scenario, plus there is also the different types of rules and laws that are implemented. They are becoming more and more green as we go generation by generation. That means 2G, 2.5G, 3G, 4G. Then as we go by, they become green, which means they consume less energy. And since energy is also attributed for the tariffs, you should expect lower tariffs for higher generations. Like, for instance, the data services that you get from 3G and 4G, equal amounts of data should not cost the same. It should be cheaper in the 4G. That is the theoretical, analysis. What was the theoretical analysis? But you might not also encounter that throughout the world. For instance, in my country, this is not the case. There is no differentiation of the tariffs of 3G or 4G, something like that. But you should expect that since energy is, money. So if you have less energy to provide the service, then you should ask the customers to pay less. Plus, on top of that, you will have management, advancement, or the management becomes easy for all IP platform. Since management costs reduce, then you should expect lower costs on the tariff. So 4G mobile technology is like that. This is the architecture of 4G. Now there is change in name as well. In previous 3G network, we had RNC, and probably we also call that Node B sometimes. But now you have also, the BTSs are known as Node B in the previous generation, the 3G. Now you have eNode B. What is different in here is that you will have a merger of Node B and RNC together. They become kind of an entity when you have 4G implementation. And to show the comparison, you can see on the top part of the slide, the 3G implementation, that is RNC connected to Node B and like that. But now you will have eNode B. Then this eNode B will have more capacity. Plus, since the carrier frequency also becomes higher, you should expect higher bandwidths. They tend to be wideband. But what is the side effect or the drawback of that? You will not have larger coverage, because the higher the carrier frequency, the higher the path loss. And since the path loss is high, which means you will have lower coverage, you are going to require more eNode Bs in a certain area. But definitely, there is increment in the data rate. Well, theoretical data rate for LTE, you might also know from your service providers, it is 100 megabits per second. Some practically can provide up to 70 megabits per second, but it all depends on the neatness of the architecture and the management and everything else. So there is theory, there is practice. We all know that there is difference. So you can see the trend towards all IP platform. At 4G, there is all IP. Prior to that, there was division of service. There was circuit switched and packet switched type of service provision. Now you have the HSS, home subscriber service, plus since it's all IP as well, the concept of mobile IP starts here. There is concept of mobile IP. You know, mobile IP has got a principle of encapsulation of IP address within another IP address. Your home agent provides you with IP, and you will get your data wherever you are by using that IP. But there should be some care of address to be implemented. Headers will increase. There are different ways of alleviating that, but still the idea of mobile IP is there. So the new network elements like the PDN gateway, PGW, and plus HSS, these are important network elements, plus serving gateway. We had earlier GGSN and SGSN. They changed to this type of naming as well as change in capacity. That means when you have the manufacturing of network elements to provide services, you cannot avoid what the previous generation can give. Rather, you add on top of that. There is backward compatibility of these network elements as well. That means 4G, 3G, 2G, they can coexist. You can also have services provided by each network if they are owned by certain operator, or if there is some roaming agreement, that can happen. The only thing that will happen will be that the limitation of the network architecture to provide you. You cannot have high data rate service in 2.5G or 2G, something like that. But you can have that in 4G. So in the radio access part, the RAN part in particular is enhanced compared to the previous, the Node-B RNC arrangement. And management becomes also easier, basically because all IP is implemented. So therefore, this is the 4G network architecture. All of them will have gateway, of course, PGW, and also the gateway MSC that you see on the top part. When you have connection to a network which is not cellular in nature, or it can be cellular, but another operator, when you have that, the gateway will be used. Plus, I would like to mention also the advantage of MPLS implementation. Probably you are familiar with it, multi-protocol level switching, which is not included in here, but MPLS just alleviates so many problems during routing and like that. You cannot have packet by packet routing when you have large volume of data movement. And if you have PGW that's operating, let's say, in the distribution or core part, traditional routing will not be implemented. Rather, there will be MPLS type of routing, which means you will have levels for incoming packets, and then you will create some circuits, and then you will have moment of large volume of data without questioning the header parts like source IP address, destination IP address. Such types of scenarios will be avoided, so that you will have low latency. Therefore, the latency of LTE is very low compared to the previous 3G and also 3.5G, which is HSPA, by the way. 3.5G is HSPA in packet access. Probably in downlink or uplink, you can also have that. Now, the 5G cellular mobile technology, it is, well, the current technology at hand, and some cities pilot tested that, and some of them are implementing it. So it is highly ambitious type of network. I mean, you will have 10,000 times more capacity compared to the previous generations, which means you should have enhancement as a physical layer, like the data link layer and others should be also changed totally. There should be dramatic change on that type of architecture. On top of that, it builds on the all-IP architecture of 4G, and then you will have flat IP implementation, as I will talk in a moment. So this is just some introduction of 5G. This is the network that is thought to be implemented, since we do not have a certain network implemented earlier. Some countries, some cities, they pilot tested it and they have got this type of architecture. But as you know, architecture changes in time. You have it, in some way at one time, but there will be rudimentary changes in the overall architecture. But the basics will be the same. What you can see from this architecture, which doesn't exist in the previous ones, is that there is device-to-device and machine-to-machine type of communication. And plus, there is massive MIMO implementation. As you know, MIMO has become obsolete. MIMO gave rise to multi-user MIMO. And then when you have larger number of antennas, 100 and more than that antennas from the base station side, you will have massive MIMO implementation. Plus, you can also see the small cell implementation, which is shown in the diagram. As you can see, this is because there is millimeter wave communication there. So you have different aspects: device-to-device communication, massive MIMO implementation, and plus, top of that, you will have millimeter wave communication. That is 30 gigahertz up to 300 gigahertz. Millimeter wave is wideband. But I also mentioned it earlier, as the carrier frequency increases, there is always some challenge, but also some advantage, because since you will have 10,000 ambitiously more capacity compared to the previous generations, this is what is expected. You can also see the 60 gigahertz implementation. This is real, that is implemented in some aspects. We should also mention the different drivers in this area. METIS is one of them, and also there is 3GPP. 3GPP is still working on protocols. 3GPP is also developing some protocol aspects of 5G, and it is highly ambitious type of development. You can also see that on the top of the diagram. So what is new in here? Like, flat IP concept is used. Flat IP. The backward compatibility of 5G to 4G and 3G still exists. When we have, let's say, 5G implementation, it doesn't mean that we are going to opt the previous 4G and 3G like that. It doesn't work that way. You will have all running, all radio access networks. But what will happen is that there will be aggregator, as can be seen on this diagram. You can see all of the previous generations there. There is GSM, GPRS, EDGE, and all of them. Then there is aggregation. Then after that, you implement flat IP. Easy to manage. Then what will be coming after that? There is a nano core. You know what nano is? It is applied everywhere in mechanical engineering, electrical engineering, and elsewhere. The concept is that you will have very miniaturized type of core, very small but very high capacity. And then there is a big architectural change, as you can see. The all IP network, nanotechnology, and plus there is one additional element, which is cloud computing. In 5G, local networks, local servers might not be in use. Rather, there will be integration of the cloud with 5G. So which allows this machine-to-machine, device-to-device communication, and also other types of connectivities that were mentioned earlier. But every type of network, heterogeneous network, you would say, because there is also WiMAX, as you can see on the left part, Wi-Fi and others, CDMA 2000, which is the derivation of IS-95 of the US. Plus, there is also eVideo, the evolution data only. All of these, CDMA 1. So 2G, 3G, and 4G all together will be aggregated, and then flat IP will be implemented. That is fed to the nanocore. So what is in the cloud? What you see on the right part is just, just simplistic interpretation of the services. All e-services will be provided, because since cloud computing is part of the architecture, and cloud computing or cloud service provision is also emerging, as you know. You have a platform as a service or hardware as a service. So there are also infrastructure as a service is one, and all the other types of service provisions will be there. And for what? For every type of service that you have in life, like defense, medicine, communication, e-governance, education. So this is a big type of leap from the previous existing 4G and also LTE advanced. We call that 4.5 GHz. So this is what we have in 5G network architecture. The flat IP architecture is explained a little bit here. It reduces the number of network elements in the data paths to lower operation costs and capital expenditure. I also mentioned that earlier. If you have lower cost in operation, in management, then you should expect lower tariff towards the customers, because you are reducing energy and also intricacy. Then you should have that reflected in the service provision. This is what we should expect. It also becomes more green. 5G becomes more green. I'm going to also present that in a moment. There is some expectation, and then the expectation is also shown in some diagram. So, excuse me. So you minimize system latency as well. Latency is very low. Like it was 5 milliseconds in 4G, then it becomes 1 millisecond in 5G. This is 5-fold reduction. So it took the advantage of all IP platform from 4G, but built on top of that, the flat IP implementation. This flat IP implementation requires more bandwidth, and that is provided by the millimeter wave communication massive MIMO implementation. So this is, let's say, it is taken from my reference AAiT, but it's simplistic and also very important type of interpretation. As you can see on the left side, it presents the trace telecom networks. You have access, metro, and core part, and heterogeneous type of networks are shown. But after aggregation, you will have flat IP in the next generation networks, like in 5G, for instance. This is a very important step. And we expect very much improvement in 5G networks. But because it is working in millimeter wave range, then what is the disadvantage of that? You will have, let's say, so many sites in certain area compared to the previous ones, because of the basic rule that as carrier frequency increases, then you will have higher path loss, and because of that, the coverage becomes minimal. You will be talking about small cells like micro, pico, and more less and less cells in size, but with high capacity. This is about the nanocore. 5G nanocore is the convergence of digital imaging technologies like nanotechnology, cloud computing, and also all IP architecture. I mentioned this earlier in the previous diagram. This is just to show you the protocol architecture, the expected protocol architecture of 5G. As you can see on the right side, you see the traditional, OSI type of representation. You have physical up to application layer, but in 5G you will have different type of arrangement. Presentation and application will merge together and they become application or service, and then transport and cellular layer, they become together one, and then OTP, Open Transport Protocol. Network layer also divided into two. This is also one of the big difference from the previous technologies. You are going to need two IP addresses per terminal. This also facilitates what we mentioned earlier, mobile IP concept. This is also important type of change. Then the other two layers, like data link layer, physical layer together, then there is open wireless architecture, OWA. This is the protocol architecture of 5G. Just some elaboration of the previously mentioned architectures. And then, so 5G will be based on open wireless architecture. The open also has some connotation that we should mention. Open and closed. As you might also know, in the previous generations, there is, some closed nature of, those layers. Like if a certain operator, for instance, is providing, certain vendor is providing the BTS, the BSC should be also from that same vendor, because they have got their own closed type of protocol within that. So this leaps out of that. Openness will be throughout the network. When it is open, then there will be more competition. If there is more competition, then there will be, better types of products in the market. And so if there are better products in the market, then you will have choice. And with choice, there will be, good type of service, good quality of service, or quality of experience in this case. Since in 5G will not apply the traditional quality of service definitions. Because in traditional quality of service, your parameters will be throughput, latency, and something like that. But they will be, a question no more. You will have gigabits per second throughput data rate, and the latency becomes on the average 1 millisecond. Therefore, there will not be problems at all. Therefore, you will have another definition for quality, which is quality of experience. This is another type of talk which can be taken, separately. So this is the network layer. All mobile networks will use mobile IP. I mentioned that. This is not a small difference. Mobile IP and static fixed IP, they are not, the same. Mobile IP has, a bigger concept and very good type of approach to enable mobility and still provide data services. You should associate handover or handoff with mobile IP in case of data. Most of the handovers that you encounter in data services are hard. That means you should first, cut the first session with some network element and then rebuild that. Soft type of scenarios are rare, but this mobile IP concept will make that easy. This is about the network layer. And IPv6 will be used, of course. It is given because we are talking about machine-to-machine communication, device-to-device communication. So many IP addresses will be required. Even one device, one network element will require two IP addresses. So this cannot be tried with IPv4. We should have IPv6 type of implementation. You will have network layer separation into to lower network layer for each interface and upper network layer for the mobile terminal. This is about the network layer. OTP, on the other hand, it differs from wired network regarding the transport layer. So in all TCP versions, the assumption is the loss segments are due to network congestion. In wireless, the loss is due to higher bit error ratio. This is also given fact. In the radio interface, there should be some change in the radio interface as well. So transport layer plus agent layer, you will have OTP. So the application or service layer, this is the one that's linked with the user, provides intelligent quality of service. As I mentioned it earlier, quality of experience, a better type of term for such scenario when it's applied to 5G. And management of variety of networks in that regard. You should also remember that it's all IP platform, therefore it is easy to create such type of scenarios. It's like having all IP platform, which was tried originally in the wired network like Ethernet and something like that. So presentation layer, application layer is application. This is also there is some comparison what you will have in the hardware and also what you will have in the software. Right? As you can see, ultra-wideband networks. We are talking about ultra-wideband networks. Higher bandwidth at low energy levels. And to ensure that, therefore, we should keep the CDMA concept running. CDMA started from earlier data networks, like you have the CDMA 2001X, you have IS-95, and also you have all the WCDMA, which has got some characteristics of GSM and also some characteristics of the American version CDMA that merged together. It created WCDMA, but still the underlying protocol, I mean the underlying physical layer implementation is CDMA or division multiple access. That means you will have let's say, direct sequence per spectrum approach, DSSS. You will have different codes for the user, for the sites, and also for the channels. That is the implementation at hand. Bandwidth around 4 gigabits per second. It's 400 times faster than today's wireless networks. Smart antenna is used, and CDMA is also, of course, the one that is implemented. So 5G will be single, unified standard of different wireless networks. Of course, this concept started from 4G because 4G was all IP platform. Then built on that, having flat IP implementation, management became easy. Latency decreased from 5 milliseconds on the average to 1 millisecond. Plus, this is ICRTECC2020 vision. This is ITU. As you can see, there are so many visions. Gigabytes in second, smart home or building. Plus, voice service is also there, but in the form of voice over IP. The traditional CS type of voice service, the legacy voice service will not be there. And also the quality can also be enhanced. Smart city creation. So lots of things there. Work and play in the cloud space. So if it were implemented prior to this pandemic, I would see a different type of approach for the e-learning systems. That is, my view. But unfortunately, it was not, widely implemented throughout the world. It is going to be implemented, but in the future, things can get easier. So that is ICRTECC2020 vision. The different types of parameters that I mentioned earlier, like user experience data rate, around 100 megabits per second, and also latency, as you can see, around 1 millisecond. So connection density, devices per kilometer square, it's around 1 million. As you can see, it is very big change. So this is just some vision. Visions sometimes can be reality, but sometimes they might not be real. But if you just wish for very big, you might not, lose the big one. That is our expectation. So this is IMT 2020 vision. The latency very low, high reliability as well. Reliability will be there because you will have meshed up connection. Reliable means you will not lose connection, since you will have the concepts of cooperative communication there. Terminals might also serve, strengthen links to sites. So individual terminals can also be used for that. This is cooperative communication. Cooperative communication is also there, plus distributed antenna system, which is cooperative communication as well. Distributed antenna system. On top of that, you will have massive MIMO from the base station end, so diversity can increase. One of the advantages when you have higher diversity, then the reliability can be higher. So all these things are envisioned. The other one is the METIS vision, METIS 2020. These are two parallel. METIS is also one of the forerunners of the development of these 5G protocols. So in METIS concept, you have massive machine communication, ultra reliable communication, which is also a repetition of the previous view. Of course, the IMT 2020 vision is also repeated in this aspect. Let me say something about SDN, because this is also very important when you have so many devices to get connected. Definitely, you will not have the traditional type of networking principle. Software-defined networking will be there. In software-defined networking, resources will be shared, fairly, equitably, you would say. You will have, the SDN controller, as you can see, probably you can see it on the slide. SDN controller will be created. That SDN controller will be the one to allocate resources. The SDN controller can have multiple switches or just IRC switches and above in the area. And therefore, if a certain user is going to connect, since the concept of cloud is already there because of this SDN, a switch near to a certain user might not serve that user. Rather, a switch which is very far from that user can be the one serving. Because it's a virtualized type of environment, the SDN concept will be implemented, software-defined networking. There are some also additional elaborations in this regard, of course, attributed to some sources, as is shown on the slide. So SDN cannot be also overseen when we talk about 5G, as we cannot oversee cloud computing, which is part and parcel of the architecture, which was not the case in the previous generations. In the previous generations, we didn't have this type of cloud concept. The servers in the vicinity were the ones that contain the data. But now that changes everything. So you will have a storage on the cloud. Services can be found from the cloud, like infrastructure or platform or software. You can get it from the cloud. Things become easier and handy. Automation becomes also, better in the case of this 5G. SDN is the one that is attributed for the networking, software-defined networking. Cloud computing is also elaborated somehow. I said lots of things earlier. Probably this is redundancy. Just finally, I would like to show you how CDMA is implemented. As you can see on the 1G, at the physical layer, there was FDMA. Then at 2G, you have TDMA and CDMA. Of course, TDMA was the European version. GSM and related, and CDMA was IS95 and the derivatives of that family. Then you have CDMA at the 3G level as well. Both European and American versions also have CDMA concepts. WCDMA being adopted from the European. So you have also in the 4G CDMA and in 5G as well. This is just to show you how CDMA is dominant type of physical layer implementation. So the green nature, that means less energy consumption, is because of the CDMA concept. It means you can depend on the code, not on the amplitude. That is the point. If you can transmit through the noise, then you are after the code, not after the amplitude, which is very essential principle. So this is comparison of mobile technologies, and with this I finalize my speech. Thank you very much for your attendance.
Thank you, Professor. So thank you very much, Badam Amasagnala, in terms of Amharic terms. Thank you very much for giving insights on various technologies, that is starting from first generation, covering up to fifth generation, and also telling us about IMT Vision 2020. Really, it was a wonderful session, and most of us got a knowledge about the architecture evolution starting from 1G to 5G. As we all know, that day by day the subscribers are increasing a lot. There are more operators are there, and more researchers are also going on. So this would have been very useful for most of the researchers who are doing research in this particular area, and also for students and also for the faculties. Now I open the forum for the participants who are willing to ask questions, so they can ask their questions now, or they can post the questions. Let them introduce. I request participants to introduce yourself, tell your name, and you can ask questions one by one.
Hello, Professor Donkey. Actually, this is Dr. Prakash from Department of Wireless Systems, Saveetha School of Engineering. I have only a basic question, sir. Can you elaborate on the jitter that happens in the 5G or the 4G networks? The latency you defined that is 10 milliseconds. What about the jitter that takes place in the networking?
Yeah, okay. Thank you, Professor. So as you know, jitter is a property of the packet switching networks. The variation of delay is what we call jitter. Like you can send some information, and then because of the all IP nature of the environment, the first part of the information might not reach to the end first. It might arrive there, delayed. This is created, because of the all IP nature of the environment. But in this 5G environment, the jitter is also minimized, because when we say, latency, this is average type of value that we are talking about. And latency is a DOM type of parameter, you may say. In order to have that latency calculated, you should have all sorts of factors in there. That means if you have jitter, for instance, then high jitter might imply high latency in the environment. Because latency is about quality of experience. And quality of experience is related to application layer, as I mentioned it earlier. So my take on your question is that the jitter will be very, very low, because the average value of the latency has become 1 millisecond. Since jitter is also one of the disturbing factors in the environment, and then since it is averaged, and also at the application layer we have got 1 millisecond or lower type of latency, then the jitter is also very low. And tell you frankly, I don't have some quantity in mind, but what I have read is that it is very low.
Very low. Okay. Thank you, Professor.
Okay.
Thank you, Professor Prakash, sir. So, any other question? Any questions from other participants?
Okay.
So, I have a question, Professor.
Okay.
One question. So, as we move from one generation to other generation, there is a lot of upgradation, both in the hardware point of view as well as in software point of view. For example, when we are moving from 2G to 2.5G, that means there has been a lot of upgrading. That is GPRS, we added SGS and GGS, and a lot of hardware are being upgraded. Similarly, when we move from 2.5 to 3G, 3G to 4G, there has been a lot of upgradation. So now, from the customer's point, that means from subscriber point of view, and also from the operator's point of view, how does it cost them?
From the operation point of view.
Yes, from the operator's point of view and also from the subscriber's point of view, how does it cost them?
Yeah, well, from the operator point of view, as you just mentioned it, some of them require a big leap, like when you go, let's say, from 2G, like 2.5G to 3G, you might have big change in the hardware. So operators would like to maintain what they have and just have more revenue on top of that. They don't want to have new equipment in the environment because that means they are going to have higher capital expenditure. So they are reluctant to move towards that direction. Whereas the user, for instance, if there is environment that's deregulated, privatized, some of them might be there providing the service by availing the change in technology. And so there might be a moment of the user from one operator to the other, deserting the user. I mean, the operator that is serving. So your question is, very, very nice. Usually the driving factors are the users in this aspect, because the users demand more services. The operator is reluctant to bring new equipment in the environment, because new equipment means larger capital expenditure, which means the operator is going to put that on the user, which means the tariff will be higher and users will not be happy about it. So if you see the change from 2G to 3G, there is a big change. And from 3G to 4G as well, there is change, but mostly software-driven types of changes can be seen. There is change in both aspects, software and hardware. But from generation to generation, you can also witness that. Like we saw from 1G to 2G, totally different. 1G was FDMA, FDD based, which means they give you expensive channel, which is frequency channel, forever. And then after that, there is TDMA. That means you are, sharing a channel for like 8 users at a time in the GSM case. So this is, my take from, from change point of view, hardware and software.
Okay, Professor. Thank you very much. So, any other questions from the participants?
Yes, sir. Yes, sir. Sir, this is Dr. Shivagami.
Okay,
hello,
yeah.
Sir. Could you hear me, sir?
Yes,
hello.
I do.
So, yes, Professor. First of all, I want to thank you. You introduced a technology very nice, in depth also. So I first thank you. Then I have 2 queries. One is 2G and 3G concern. People are bothering about radiation much radiation is there, and so many journals. Yes, 2G and 3. Till now, 3G radiation analysis is going on and the research is going on. Proven results were there as far as Journal of Clinical and Diagnostic Research concerned. And how about 5G concern as far as radiation? Since all the technology, it is touching all the technologies as well as variety of network it crossed. So how about the radiation, Professor? This is
good question.
This is one part, Professor. And sorry for the interruption. And let me pause me.
Okay, your second question. Your question is about frequency, right? The frequency that is being used. Is that so? Frequency and health issues is the one question. Is it frequency? If you ask me, is the one that raised the question. The first one I heard about frequency, and the other one was.
The first one was related to the radiation.
Yeah, radiation, health issues.
Yes.
This is a good question. By the way, there are so many researches going on, and as you might be aware, as you have higher carrier frequencies, then the thing is that you will have the principle of the photon content. Probably you might also know that as you have higher carrier frequency, the HF type of formula that from calculation of particle property of light and radiation and something like electromagnetic wave, you have higher energy as the carrier frequency increases. But the thing is that the radiation becomes higher, but there is no proven type of work till now, to my knowledge, that can tell you what type of health issue or the radiation that can bring about some sort of disease or something like that. There are hearsays. The question also, in the question it was mentioned, there are researches going on, but there are no researches that can tell for sure that a certain type of radiation problem is related to a certain type of wireless communication related type of communication. This is what I have in mind till now. But the thing is that we cannot deny this. As carrier frequency increases, then there is increment in the energy content. We are also immersed in electromagnetic wave. You know that, because there are so many types of transmissions, be it TV, radio, or cellular network. So many of them. But as to the question, there is no paper that attributes some radiation problem with some sort of communication. It is just a general type of term that I hear all the time. And I haven't encountered a proven type of paper. Like they can say for cancer, cancer can be caused by this, as much as they say because of different types of other parameters in the environment. So probably my response might not be sufficient, but that's my take when it comes to the radiation. But one thing is true: as generations increase, then you will have higher carrier frequencies because we need higher bandwidths. And then the higher the carrier frequency, then the higher the energy content. But how much the effect is going to be is to be witnessed, particularly in the coming 5G network. Since we are going to have machine-to-machine, device-to-device communication, probably it might come out vividly for the researchers, because lower carrier frequencies, the impact is not that visible. That's my take for your question.
Okay, thank you, Professor.
Thank you, Professor.
Yes.
Thank you, Professor.
There is also any other questions from your side, ma'am? Okay, is there any other questions from participants? Any other questions from participants? Okay, so if there is any questions, I have your email ID, Professor. I just take the questions and also I will mail the questions so that you can reply them back in the email ID also. Really, we thank you very much, Professor, for accepting our request and giving us a wonderful keynote session for this international e-conference on recent trends in electronics, computing and communication engineering, organized by Institute of EC, Saveetha School of Engineering, SIMATS, and
I think it's not only good, I think.
Okay, sorry, Professor. Sorry for disturbance. So once again, so this was a wonderful session, Professor. Thanks for accepting our request and in this short span of time, and you have given a wonderful session. And it was a wonderful keynote session for this international conference on recent trends in electronics, computing, and communication engineering, organized by Institute of EC, Saveetha School of Engineering, SIMATS, and so day by day these papers are increasing, and a lot of research is going on in this area. So we thank you, Professor. We thank you very much. Madam, thank you. Thank you very much, Professor Badam. I also thank all the participants who joined this session. Thank you very much.